Okay, so this is week 3 of 4 of part 2 of Kepler's New Astronomy. We're going to cover the rest of Kepler's book, what Kepler presents in part 2 directly today. And then next week, as I said, I wanted to take a little bit of time and reflect on what Kepler does in part 2. Obviously, we don't have a full, complete understanding of everything Kepler does in the entirety of his work, and it is very important to take the New Astronomy, but also to take that together with his work, The Harmony of the Worlds, and also his Mysterium Cosmographicum, to get a full insight to Kepler and his revolution. But I think even from the standpoint of what we get in book 2, part 2 of the New Astronomy, I want to take some time next week to look at that from the standpoint of Cusa and Cusa's method of thought, in particular his De Docta Ignorantia, with some specific references to some of what Cusa comes to as paradoxes and conclusions in his second book. So today we want to conclude the focus on Kepler's part 2 itself directly before next week kind of reflecting on some of what we looked at in Kepler's work. I just wanted to situate a little bit, resituate what exactly we're looking at, because to get the how profound this whole New Astronomy, in particular this section, is, you really have to be thinking about it with some very fundamental questions up front. Namely, what is knowledge? What is human knowledge? What does it mean for the human mind to know something? How does the human mind know something? Another way to pose it, how can the human mind understand the causes of things in the universe? We can observe things, we can observe changes, we can notice changes, but how much can a human mind, a human being, understand causes, reasons, the fundamental reasons why certain things happen? And with the planetary motions, that's obviously been a subject of investigation for mankind for thousands and thousands of years. You go back in pretty much any developed ancient civilization, and they were watching the motions of the stars. And it was known that you had these wandering stars, these planets. And so the question of what is happening in the nighttime sky and why are these planetary bodies moving around has been, and at Kepler's time had been already, a question for thousands and thousands of years for many, many civilizations. So these are, this is one of the biggest scientific questions that mankind had played with and looked at for many, many, many generations. And if you think about it, what you're really asking in asking these kind of broader philosophical, so to speak, questions is, what is the relationship of the human mind and the universe? Things are changing in the universe. Things are happening. We can observe those changes happening. But can the human mind actually know or discover or actually fundamentally understand why these things are happening? Why the planets are moving the way they're moving? So to get a real insight and understanding into the significance of what Kepler does, you have to keep those questions up front. Throughout all the laws of sines and laws of tangents and all the calculations involved throughout the book, you want to make sure you're keeping up front these broader questions, because that's what we really want to, that's the point, that's what we want to get at and understand. So one thing that we have to test knowledge, how do we have knowledge of why something's actually happening, do we have an insight into what causes certain things to happen, is a question of forecasting. Can you forecast into the future and determine and know what an outcome is going to be before it happens? Or are we kind of playing with this a little bit with this vicarious hypothesis construction? You know, you can play in certain conditions. You can even look at hindcasting. You develop a certain conception, and then you can take that conception backwards in time and say, does this conception actually match what was known to be observed or be occurring at this previous time? So that's something we have that we're kind of playing with here in developing this vicarious hypothesis model. From our observation, from the work we did in developing this model, can this thing actually forecast and hindcast, and can it actually model the, can it express and accurately tell us the motions of the planet Mars in an accurate way? So that's what we're looking at here. And what we found with this specific model that Kepler developed with an incredible amount of rigor, an incredible amount of precision, is that we found a model that, for all intents and purposes, would match the observations of the motion of Mars to within any observational error. That it was as accurate as could be desired for any model in determining where Mars was going to be on its orbit at a certain time. And just to make sure everything's totally clear in going into this, just to refresh on how this works, we have our equant, we have the orbit, Mars moving on this circular orbit. We have this equant, this point of uniform motion, and really that governs the orbit. That determines the motion of Mars. That determines the whole model, so to speak. Maybe just to go to an example here. If we were to so to take this was actually one of your homework assignments here. Was this worksheet? This comes a little bit later, but I'm going to pull it ahead of time just to look at it. If you wanted to know where Mars is going to be, say you were starting here, say you knew Mars is right here on its orbit, and you want to know where is Mars going to be in a certain amount of time. This particular diagram would correspond to starting from here, 593 Earth days of motion would bring Mars to here. So say we wanted to know from the point we're at now, where is Mars going to be seen by the Sun in 593 days, just to pick a random example to correspond to this diagram we have right here. You can convert, again, the time into an angle from the equant, and you could either run the angle around this way or just take 360 minus that value and put the angle in here. And this model then should be able to tell us, this model tells us where the equant determines where Mars is on its orbit. And we're dealing with a situation where the orbit is a perfect circle orbit. So what we have is basically a model we've developed where we're going to follow two paths here. Kepler basically follows two paths. So last week we followed one path of investigation focused specifically on these longitudinal motions. So we had our opposition observations. We had the time between them measured from the equant, and we had the angle seen from the sun, and examining how to get those to best intersect each other and determine one orbit. Following that path of kind of logical mathematical investigation took us to one very specific conclusion for the nature of this orbit. For the position of the equant, this point of uniform motion which determines the model, which determines the motion of Mars around its circle, and the position of the center of the orbit relative to the sun. So we took that entire path of investigation, and we came to this conclusion, and we got a model that, as we looked at last week, was able to match each of our observations with an extreme degree of precision according to Kepler's time. So we have something that could forecast where Mars was going to be and hindcast where Mars was seen with an incredible degree of accuracy. So that's our vicarious hypothesis model. And it's kind of funny because we're about to show that it's not true, that it can't actually exist. But throughout the rest of the book, Kepler continues to use it, which is kind of a funny irony, funny thing, because he knows it's not true, it's not what's actually happening, but it's able to simulate Mars's motion to a fine enough degree that he actually uses it later in the book to test other hypotheses and other models against. But what we're going to do now, because we're not concerned, again, we're concerned with these bigger questions that we posed in the beginning. We have this model, it forecasts Mars's motion with incredible accuracy. But we're not interested in just having something that will tell us, having something that tells us where we're going to find Mars. That's not what Kepler's interested in. He's interested in knowing, can I understand what is the cause of the planetary motions? Can I understand why the planets are doing what they're doing? Can I understand the fundamental reason behind the planetary motions? And again, it's this more fundamental question of what is the relationship of the human mind and the capabilities of the human mind to understand causes, principles in the universe. So despite the fact that this thing is incredibly accurate, we're now going to follow on a second path of investigation to try and determine a better understanding of Mars's orbit. So this was something that everyone should have worked on in their group sessions, and part of this is included in the homework. But just to give an overview of it, Kepler then takes up the question of investigating these latitude measurements. So before, what we were looking at with the vicarious model was just the solely the longitudinal motion of Mars around its orbit, and not being so concerned with the motion of Mars above and below the ecliptic. Now, Kepler says there's another way we can investigate the validity of this eccentricity we determined here, and that is by this second path of examining the latitudes. And so what we have here is, this is from one of the homework assignments, is Kepler's, so you have the plane of the Earth's orbit here, with one extreme at C, the Sun at A, another extreme at B, and then the inclination of Mars's orbit relative to the Earth's orbit. And because Kepler's able to determine the inclination between the orbits, represented by this angle here, and he has observations of where the Earth saw Mars at these extreme points in its orbit, he's able to then come back and calculate the distance of Mars when it's at that extreme point to the Sun, and then similar on this side, and through this method directly calculate what the eccentricity or the distance between the center of Mars's orbit and the Sun would be. And this is interesting because it's kind of it's a more direct way of determining this value than we had in the previous method of the vicarious hypothesis. Here, remember, we were playing with the these lines of sight animations and kind of moving around these this equant angles and the line of sight angles till we got something that till we got a configuration that would best fit the observations. And the eccentricity was then determined by just the positioning that would best fit the observations. But here, we're actually able to do something that's significantly more direct. And through direct measurements and calculations, Kepler can actually effectively measure what this distance here is. And this is a more accurate determination of what we would expect, what we can determine and know this eccentricity, this Sun-Earth distance is, through this method of the latitudes. So again, it's like taking a second path to come back and calculate something that supposedly we already have. You know, we already determined that value in the vicarious hypothesis method here, but now we've taken another route, tried a different way, and calculated it again. So what Kepler then does is compares the values. And we can see here that in this second method, we get something very interesting, a significant difference in this eccentricity determined in this latitudes method. The value we got from the vicarious hypothesis was about 11,300, and depending on exactly how you calculate the eccentricity with the latitudes, you get something in the range of about 8,000 to 10,000. You get something a good chunk less than what we got with the previous method. So right away that should jump out as significantly anomalous. Why, in taking a second route to determine something, would we get a different value for this measurement? You know, this immediately jumps out as an anomaly. I was trying to think of different metaphors or examples to illustrate a similar paradox coming across. It was kind of difficult to think of some, but one, maybe we can get into a little bit later. I was trying to come up with some geometry examples of moving around on a sphere, or thinking you're moving around on a sphere, and certain anomalies coming up in your motion which would allow you to determine the curvature as something that not what you expected based upon your initial assumptions. We can maybe play with that a little bit later, but it's right away should be a big question why we got this different value when we assumed we were measuring the same thing.
Hey, Ben?
Yeah.
I think that The Pit and the Pendulum by Poe is an example of exactly that. I'll look at it and send you something on it.
Also, Ben, when police officers interrogate two different suspects involved in the same crime to see if their stories match up. Kepler interrogates the longitude, gives one story, and then he interrogates the latitude and gives another story. So he says, "Oh, you guys must be lying."
Right. He locked them in different rooms before they could talk to each other, and yeah. Yeah, no, I think it'd be a very useful exercise to try and write up other examples of similar qualities of anomalies that come up in investigation. It's been a while since I read that particular Poe story, but so that would be, yeah, if you want to pull some thoughts out on that and write it up, that would be great. Something worth sharing on the next class even. So what Kepler has here is he sees that the value he has for this eccentricity determined by the latitudes is actually very close to the what you would get if you had bisected the total eccentricity, which he had earlier said he wasn't going to assume needed to be done. So that's why he used the 4 observations instead of the 3. But then he notes, interestingly, he says, well, maybe this whole discussion of bisection wasn't such a bad idea to think about after all, because the value that he gets with the latitudes determination actually ends up coming very close to a bisected eccentricity. So now what does he do? He has this new eccentricity. He's got this different value. So now what does he do with it? Well, it's, again, a more accurate determination. The way he calculates it with the latitudes is actually more of a form of determining what it really is, as opposed to kind of getting it secondhand by curve fitting these motions. So then he turns around and says, we should take this eccentricity determined from the latitudes and put that into our model, and then again test to see how accurate the model is with this more accurate eccentricity we've determined. And here we get this very significant breakdown. As soon as he does this, and as soon as he puts in this eccentricity, which he knows should be true, the model no longer works. You have a very slight but significant difference in where the model says Mars is going to be and where the observation had shown Mars to be. As you can see here, this is the value he gets from the bisected eccentricity, which he gets from the latitude model. And it says Mars should be seen at this time at 17 degrees 4 minutes Cancer. But according to the observation, it was seen at 16 degrees 55 minutes for a total difference of 9 minutes. Whereas the vicarious hypothesis model itself had shown Mars to be at 16 degrees 57 minutes, only a little bit more than a minute different from the observation, but again significantly different than this bisected vicarious that he's now using a more accurate eccentricity to determine. So now we're just caught in this big paradox. If we use an eccentricity that we know should be true, then the model no longer shows, in certain situations, it fails, it breaks down, it no longer simulates or models the motion of Mars around its orbit. When we use motions of Mars that we know do simulate the motion of Mars around its orbit, we're forced to use an eccentricity that we know isn't true, that we know can't exist. So you can't have both. You can't have both at the same time. You're either lying one way or you're lying the other way. You're either talking to the longitude and lying about the latitudes and the eccentricity behind their back, or you're talking to the latitudes and the eccentricity and you're lying about the longitudes without them knowing or listening. So, this is and again, I read this quote from Kepler in the last session, where he explicitly makes a very clear reference to the Socratic method of dialogue in discussing this anomaly coming up. That if we start from a certain basis, and then we follow a logical argument, or in this case, two logical arguments, mathematics being a form of logic. If we follow two logical arguments through calculation, we find that they come to results that cannot be reconciled, that cannot come to a single resolution. Despite all the details involved in the calculations, this method of determining the eccentricities of the vicarious hypothesis model we were playing with last week here is a series of logical mathematical steps, in this case a series of approximations that has one and only one path to follow, and you can follow it to its logical conclusion and you reach one result. That was our first path. If we then turn around and take this second path, a relatively simpler one, an easier path, we again follow a series of mathematical calculations, logical steps, and we come to, again, one and only one conclusion. But then when we compare it to the results of the first path, again, we come to this fundamental irony. We have an inconsistency in the results from two otherwise flawless sets of calculations. The error wasn't in the calculations, it wasn't in the mathematics, it wasn't in any of the logical steps that Kepler took along each of these paths. So then where does the error lie? It's not that he forgot to carry the two, and then that's why the whole thing broke down. So again, he has this quote where he's clearly referring to a Socratic method of following a logical sequence, he says, either in dialectic or other forms, that reaches a point of absurdity. And what that method allows you to do is then call into question the fundamental assumptions, the initial assumptions that were posed in the beginning, which created the framework to govern those logical steps from those assumptions. So what we have here is, it's easy to take a few minutes just to kind of describe it through and discuss it, but it's certainly one of the most profound points, and especially when you go through it and then step back and look at some of the implications of the whole thing, one of the most profound points in the whole work of the new astronomy is the method by which Kepler is able to not determine that the system of Copernicus is correct over Ptolemy, or Brahe is correct over Copernicus, or any other variation therein, but instead to go outside of the whole framework of discussion and say the language these guys were using, the logical framework they were working in, was itself fundamentally flawed. That more important than any of the variations that any of these guys used in their models was the initial assumptions upon which the entire models were built and determined and structured. And so what you have here with this 8 minutes of arc, which Kepler says forms the basis for an entire new astronomy. You have the critical error, the critical inconsistency that shows that no matter what you do, from the standpoint of these assumptions we started with, the existence of perfect circles for orbits and the existence of any point of uniform motion at all, no matter what you do within that framework, you cannot come up to something that actually is true. That truth cannot exist within the geometry of that framework, of that system. That either the circle or the equant or both has to not exist, has to be false. And it's important to note that Kepler certainly probably had certain ideas about that earlier on, but he doesn't just state it and then assert it and then just go on. He actually structures his entire work, as we saw in part 2, to take the reader through the process of being able to demonstrate for themselves the failure and live themselves through the demonstration of the failure of these assumptions. So people to actually, in a pedagogical way, take people through this process of discovering the breakdown of this whole equant perfect circular framework, which then opens up a new question of basically physics. What is actually governing? What is the cause then of the motions of the planetary orbits, of the planets around their orbits?
Yeah, Ben?
Yeah.
Yeah, that is the Socratic method, because he lives vicariously through, Copernicus, Ptolemy, and Brahe, and just like Socrates, with his interlocutors, he'll run out their logical formulations until they make themselves look absurd, until it comes to something that is beyond how they were approaching the way they were thinking. So just like Kepler, he runs out the way they're thinking until he gets them to prove that they're wrong in a Socratic way.
Mm-hmm.
Yeah. It also kind of reminds me of the thing that Lynn always talks about in the In Defense of Common Sense about the systems, the axiomatic systems. You have the axioms, and then from the axioms you have the theorems, and you have this massive structure of theorems based on all these axioms. And Kepler just like tears down the axioms. Just kind of reminded me of that, where he's is what, like what Lynn says about the 3 different hypotheses, that this is like the second form of hypotheses, the higher hypotheses, where he overthrows the accepted axioms. Kind of reminds me of that's what Lynn described there. That's what Kepler. That's what Kepler was doing.
Yeah, exactly. Again, I think it's worth, as has been posed, I don't know if anybody has any reflections or comments based upon the essays in the homework on the writing assignments. I really think it's worth thinking of additional parallel examples to really work through to get kind of a generalized sense of this method of thinking. Here we have, go through the relive the way Kepler does it in this particular example, but I think it's then worth really thinking through how to find other expressions or other needed expressions for similar examples in other areas in need of today. Like I referenced in the previous class, the initial context in which Lynn posed the challenge of working through Kepler's new astronomy to the then youth movement was very explicitly and clearly tied to understanding economics and understanding real cause and the real science of physical economy, as opposed to just statistical methods of curve fitting and approximation. But how do you actually find what's governing a national or a global economic process from a real physical standpoint, as opposed to just modeling certain motions? So I don't know if anybody had any thoughts or comments from the essay questions in the homework, but I definitely think that's a critical element of this, is taking the time to think through and work through some of these broader questions for yourself.
I think it could definitely be applied to the organizing, like in politics, because people have their axioms, and then they have this whole like system that they construct based on these axioms. And it's funny because you can get into a fight with people, and if you don't get at the axioms, then it's like you're just like cutting off the head of the Hydra. 2 other heads just grow back, which is what happens, is that you might like disprove a theorem, but they still they come back and create another type of thing, another type of theorem. So it's definitely, I think it's useful to kind of keep in mind that some of this stuff, like you don't want to be like, you don't want to take someone through a literal platonic dialogue on the phone call or in the field, but it's definitely useful to keep in mind the method.
Yeah, absolutely. So certainly, unless any more on that, and leading into next week, I think the main thing people should really have in mind, assuming people did the homework and did the working assignments and have worked through this presentation of part 2 of Kepler, I think it's going to be crucial to really put some time in reflecting on over this next week, looking at that from the standpoint of Kuza, and again these broader questions that I opened with of what is the nature of knowledge really? What is the nature of the relationship of the human mind to the universe? Now we're kind of left with an open question. We know that this system we're dealing with cannot possibly work. That there's nothing we can actually do within this predefined framework of these types of motion, of uniform motion, of circular action, which can possibly be what's actually happening in the heavens with the motion of Mars. So then the question is, what are we left with? The two questions that we really need to fight through. And one is, what was the axiomatic basis of these assumptions that we now know cannot really be true? What is the origin or genesis, or what's the kind of basis for these initial assumptions? And two, can we actually know what's really happening? And if we can, how does the human mind actually know that? Now, I think the first question should be reflected upon from Lynn's very long-standing and emphatic and strongly emphatic emphasis on the fallacy of sense perception. And I think we should work through understanding the very fundamental concepts of uniform motion and of circular action as existing as derivatives of and expressions of a kind of generalized sense perceptual notion of action and change in the universe, of geometry, so to speak. That fundamentally it's all rooted in certain assumptions or ideas you get just from your experience with your biological apparatus, your sense perceptual apparatus. That these notions, the genesis of these notions is rooted fundamentally in that. But then what we see here in this demonstration, in this remarkable demonstration of part 2, is that that entire framework cannot, that the universe cannot exist within that framework. That real cause, the actual determining cause of the planetary motions, cannot exist within that framework. So that leaves us with a very serious question then. If we cannot know things through sense perception, if we cannot know cause through sense perception or any logical derivatives of sense perceptual notions, then are we either left, one, with no ability to know cause at all, because sense perception fails to actually encapsulate cause in the universe? Or two, does the human being, does the human mind have another capability for accessing and having some type of relationship to cause in the universe? And these are the questions that Kuza takes up in Learned Ignorance, in the De Docta Ignorantia. And I think these are the questions that we want really rooted throughout the working of the new astronomy of Kepler and looking at it from the standpoint of Kuza. Does that make sense? Are those questions clear, or is that kind of coming out of the blue? Is that too general? Is there any other questions about from the homework in particular, or from any of the sections in the assigned work? Did people enjoy the homework so much they wanted to keep it for themselves?
Hey, this might be a little off topic, but when you were talking about the paths of investigation and the different paths Kepler took, it was so funny because like I immediately started thinking about that little metaphor that Kepler puts out at the end about the chaste maiden and the Jezebel. Is that what he was like referring to, or something? About the bleary-eyed logicians, like they can't tell the difference, you know.
I'd have to look more. I couldn't recall off the top of my head. I'd have to look more closely at that chapter. Does anyone else in the room has an answer to that? I remember the quote kind of vaguely.
Hey, Ben, could we go through Chapter 19, Worksheet 2?
Here?
Or we could also do it.
Well,
We could also.
we'll do.
I was going to say we could also do it ourselves here, but there was some, we wanted to go over it here, but if you don't want to do it over the Skype, it might be, it's up to you.
Yeah, I don't know if this is the best format for it.
Okay.
Were you guys all stuck on it there, or just a few of you?
Just a few.
Yeah, if we want, we could. If it, you guys can give another shot together, and if it's still not clear, we could definitely go over it tomorrow or the next day, or find some time.
Okay, good.
So, any other broader questions or comments on the whole book, or where we're going with this, or the relation of this to the educational initiative that Lynn's put out? Well, if not, I would just reiterate again this bridge between what we're going to look at with Kusa next week, and what people should make sure to take the time between now and then to go through. This bridge between what Kusa is tackling in Learned Ignorance and what Kepler demonstrates here, I think, is absolutely critical to keep up front and in the front of the mind when going through this work. And realize that we are dealing with these most fundamental and profound questions of what is the role of the human mind and the relation of the human mind to the universe as a whole. And this becomes, as Lynn has put up front clearly, this is the fundamental basis of the Renaissance overall. A shattering of a certain wrong framework of science and really of claiming what the human mind actually is, and a revolutionary demonstration of a much higher and more profound conception and more truthful conception about the interaction and the capabilities of the human mind as a creative factor in the universe, which comes from the powers of the human mind itself and is not mediated through these fallacies of sense perception. And Lynn has been emphasizing the relationship of Kusa's investigations in the conception of the very large, Brunelleschi's investigations and demonstrations from the standpoint of action in the very small, and then here we have Kepler's, what he called Kepler's resolution to the culmination of the work of Brunelleschi and Kusa. And I think it fundamentally centers around this question of the nature of the human mind and the relationship of the human mind to the universe, and the demonstration that it does not exist in the entire framework of sense perception. That fails. You can show that it fails, it doesn't work, but then more importantly, you can demonstrate that the human mind does have an efficient power and capability to know the universe and to be a factor of creative change in the universe. And this, I think, as far as I understand Lynn's emphasis, this scientific understanding becomes the root, the basis, the seed of the entire development of the Renaissance and this complete new blossoming of a new era of human civilization. And I certainly think that he thinks if we don't have that as part of the political and strategic shift that we need to create now, that I think he's not going to be happy with what he the type of shift that we need to create is of that magnitude, that we need to actually have a similar more profound discovery of a higher scientific understanding of the role of the human mind and the nature of the human mind in the universe. That has to be demonstrated on a scientific basis, and that has to become the point of genesis of this entire new system that we're talking about. That it's not just simply a set of laws or arbitrary policies, but it's all subsumed and grows from a single conception, a single scientific conception of the role of the human mind and mankind in the universe. And that's exactly the questions that we're trying to struggle with and fighting through here. And that's exactly what we have to take into the current fight, the current situation. That's what we have to represent. That's what we have to create as a fundamental contribution to the type of historical and political shift that we're creating right now.
Hey, Ben.
Yeah.
Hi, it's Anastasia. I just wanted to say that I hadn't really worked through the vicarious hypothesis before, and I remember there was a point where Lynn was really, really emphasizing the vicarious hypothesis in his papers. And going through this, some of this work with you when I was over there, it all of a sudden just kind of clicked. Like, oh, so this is what he meant by calling the vicarious hypothesis a metaphor for discovering what truth is. Because, both these, you get two totally different things. We were joking around the beginning, but then the mind's able to realize that, well, there's got to be something wrong that I'm assuming here to begin with, which leads you to trying to investigate what those things are to seek out what the real truth is. So anyway, I just thought it was useful in reflecting on these old papers that Lynn had emphasized the vicarious hypothesis.
Yeah, we're kind of stuck at a point of, we haven't exactly reached the resolution, obviously, yet. We've kind of hit the paradox. So now we get to sit on the paradox for a good chunk of time as Kepler fights to develop the resolution to this otherwise insurmountable inconsistency we come to from these two paths. I think the way Jason described it in the overview class he did a few weeks ago, we've now shown that a framework of motion of equants and perfect circles can't be truth. But then now what do you have to work from? Where are you? He described it as walking into a completely dark cave, a dark room, and you have no idea, you have no map, you don't know how to get from one place to another. You have to begin to feel out anew an understanding of what this new geometry is. And so we're kind of stuck at that now. We want to really get in our gut this contradiction that we've now forced to the surface. But now that becomes that contradiction, that inconsistency, the failure of the existence of this framework to account for what we know. That becomes now the substance, the basis, the stool, so to speak, to then search for, to stand upon, to search for some new cause, to hypothesize some conception of physical cause, which is then what Kepler's going to take up in the coming chapters, in the coming parts. Any other thoughts? Hey, Dan, do you want to say any more about your pit and the pendulum analysis or analogy? Or do you want to share that in another format?
I have to go back and read it. I was hoping that someone else would remember it better, but I'll have something on it next week.
Okay, look forward to that. Okay, unless there's anything else.
Well, I have an idea of what Dan was talking about with the pit and the pendulum, because he's in a pit and he's been there for days and he doesn't have a sense of where he is. And at a certain point, he starts feeling along the wall, and realizes that the wall is in a circular place, like it's in a circular, it's in a certain shape, and then he does another test where he throws a rock and listens for the echo, and he finds out that there's actually a pit, and it's a whole, it's basically him, testing out what his surroundings are without knowing anything. And it's very similar to this.
Anything else? Okay. Hopefully that's a stimulus and the right kind of framework to then go into next week. And look forward to that. And people should definitely take the time to work through these questions and the writing assignment, homework in particular, and then really make sure you have a chance to take some time to read Kuz's work. And if you need people to be available to go through it with you or be able to ask questions to them, you should make sure that's set up so that's available. It's going to be kind of difficult if it's just your first time sitting down reading it. So with that, unless there's anything else, I think that'll do it for this week. And talk to you guys next Wednesday.
Thank you.